In section 1.4, we're going to talk about prefixes and powers. And we're also going to take up here the Greek alphabet as additional symbols, because that's so important in this arena. Prefixes and powers. Well, what does this mean? Well, in the SI system, it is so easy just to move the decimal point that it was realized that we shouldn't have 12 inches in a foot. We should have 10 inches in a foot, or something like that. That way we can simply move the decimal point to convert one unit to another. And that is the way the scientific international system is set up, so that all of the other units are multiples of one fundamental unit. For example, the kilometer is a kilometer, 1,000 meters. And so if we have a measurement in the kilometers, like 2 kilometers, we can convert that instantly just by moving the decimal point and get 2,000 meters. What are these prefixes? Well, it turns out that we have named all the prefixes in powers of 3. That's like where we put a comma in with our normal notation. That would be 1,000, a million, a billion, which is called in the metric system giga, a trillion, a tera, which is the same thing, 10 to the 12th, peta, 10 to the 15th, exa, 10 to the 18th, zeta, 10 to the 21, and yada, 10 to the 24th. You should memorize each of the prefixes for the positive powers and for the negative powers. It's kilo, mega, giga, tera, peta, and exa, zeta, yada. Likewise, to make things smaller, we have the milli, like the millimeter, meaning 1/1000th, 10 to the minus 3 of a meter. We have a micrometer, or a micrometer, a millionth of a meter. A nanometer, 10 to the minus 9th. That's 1 billionth, as you can tell. And we don't use those terms billionth and trillionth here, although you should know how to convert back and forth between those words and these, and I'm going to show you that in a second. So, and you hear a lot today about nanotechnology. You remember a moment ago we talked about the angstrom is 10 to the minus 10th meters. Well, that's really not a formal named length here or prefix. So the angstrom is just kind of sticks out as having been convenient. But what it is it's 1/10 of a nanometer, 10 to the minus, in other words, an angstrom is 10 to the minus 10th meters. Pico, you hear some about a picosecond. A femtometer, we've already talked about. That's the width, about the width across a proton. Then you have an atto, 10 to the minus 18th, zepto, 10 to the minus 21, and yotto, 10 to the minus 24th. You notice that these end in O, where these end in A. Remember, the A's tell you something that's a positive power. The O's tell you something that is a negative power. There are some other ones that are used, and you've certainly heard of the centimeter, 10 to the minus 2, and maybe the decimeter. These end in I, so they're a little bit different. Also the hectometer, which is 100 meters, and the deca, as opposed to the decameter, which is 10 meters. That would be about 30 feet. Since a meter is about 3 feet, a decameter would be about 30 feet. These units are important, and we use them constantly. We need to know common names for units also. And incidentally, all of those units, all of those prefixes, and all of these other units are contained in the units program. And so that's very convenient when you're converting things. You can even use words like 1,000 or a trillion or a femto and merge all those units together, and that will come out right. Let's look at some of the common names. You know what a dozen is. 12. A gross, that's 144. A ream of paper is 500 sheets. 1,000, of course you know what 1,000 is. A million, a billion, a trillion, a quadrillion. Do you know the rest of them? Well, let's see if you can guess. When I get to 1,000, that's 1,000. 1,000 is going to be what? 10 to the third. A million is 10 to the 6th. In other words, 10 to the 6th, that would be the same as mega. up here. A million. A billion is 10 to the ninth. In other words, it's going to be the same as a giga. So we would say not a billion meters, we would say a gigameter. And you hear giga a lot of times now referring to the size of disk drives. A gigabyte, and that's heard all the time, and a byte meaning a byte of information, or a one character, which is 8 bits of information. And so if I have a character like a capital X or a small f, then each of these characters contain 8 ones and zeros that make it up inside the computer. These ones and zeros are called a bit of information, and that 8 bits, 8 of those bits is called a byte, B-Y-T-E. And so what you hear a lot of is a gigabyte, meaning you have 10 to the ninth bytes. If it's a gigabit, then that's a little bit different. It's only 1/8 as much. So our billion is a giga. And after a billion, do you know what's next? A trillion. Of course, you know a trillion. And a trillion is going to be 10 to the 12th, 9, 10, 11, 12. And if I look here, that's the same as tera. So a trillion is like a tera. The T's can kind of help you there remember what that is. Then after the trillion, I want you to notice that this bi here and this tri are like the prefixes that we have in many languages. A bi, tri, and what would be next? What would be this thing that we now call the peta, 10 to the 15th? Well, a peta would be a quadrillion. 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 That's an R there. A quadrillion, 10 to the 15, 16, 17, 18, which is exa, would be a quin, Q-U-I-N, a quintillion. Can you guess the next? Trillion, billion, bi, tri, quad, quin, quadrillion, quintillion, sextillion, septillion, octillion, novillion, decillion. And these give it the regular powers as we go up in what is called the normal English. Check those out with the units program and make sure that you can convert anything from these numbers to these prefixes and back and keep it all straight. And remember, we do have common names for things. You have even things like a baker's dozen, which is 13 presumably, and other things like that have become very common. These prefixes are all used to give powers of 10 in units of 3 each thousand, jumping by 1,000 each time, to all of the different scientific international units. So we have something like a microsecond, a nanosecond, a femtosecond, a femtometer. We could have a femtokilogram, although we wouldn't write it in that way. Of course, the gram itself is 1/1000th, and that's where we get the kilogram. That's the standard rather than the gram. Anyway, practice with these units, and you have to make sure you know them, because we're going to assume that you know them for the rest of the course. That's something you need to know in life, everything from computer science to measurement theory. Let's talk about the Greek alphabet. Why on earth would we use the Greek alphabet? Well, when we're talking about symbols for things, X, Y, and Z, and A, and B, we run out of letters. There are 26 of these and 26 of these. And we'd like to use letters that kind of always stand for the same thing. And we don't have enough of these to stand always for the same thing. For example, X, Y, and Z, and often U, V, and W are used as unknowns in many places. And we like to use the small or lowercase letters rather than the uppercase or capital letters. So it turns out that it's very useful to use the Greek letters. And in most of our science courses, in all of medicine and areas like that, we're constantly having to go back and recognize what these are and what they're named. And so you should know the names of the Greek letters. And if you don't, look them up in your book. They're in the inside one of the covers. And here are the lowercase Greek letters and the uppercase Greek letters. Many of these you know from fraternities and sororities. Many of them you know from other types of organizations or other usages. And of course, here's alpha, beta, gamma, delta, epsilon, zeta, eta, theta, iota, kappa, lambda, mu, nu, xi, omicron, pi, rho, sigma, tau, upsilon, phi, chi, psi, and omega. And likewise for the uppercase. And so you really need to know all of those names and be able to recognize them, because we'll be using them for different types of scientific meanings: distances, thermal conductivities, temperatures, angles, things of that nature. For example, theta is always used as an angle, and sometimes phi or phi.